Hello everyone, welcome to Basics e-learning.
In lesson number 2 video of network analysis, I am going to discuss few problems on Kirchhoff's laws, both applying Kirchhoff's current law and also Kirchhoff's voltage law. In my previous lecture, that is in lesson number 1, I have explained the concept of Kirchhoff's laws, both KCL and KVL, and how to apply on any given network, that is the sign convention part. So the lesson number 1 video of network analysis, I am going to leave a link in the description box. Please check it out. The first question here is, applying Kirchhoff's laws, find the various branch currents of the given network. So here this is the given network. So first thing after taking the circuit is mark the nodes. So here I am marking A, B, C, right? D, E, F. So follow the video carefully. Step by step I'll explain here. So take down the currents in each branch. So let us start from here. That is from the source of 50 volts, right? So from here I will be trying to mark the currents. Suppose say the current that is delivered from this 50 volt source is I1, right? So as you don't have any other branch here, so this I1 current will flow through the branch AB, right? So in the branch AB also I have current flowing is I1. Now coming to node B, the node B will divide the current, right? At node B you have two branches, that is BE and BC. So the current that is entering into this node B, that is I1, will divide now into two branches. Suppose say the branch B current is I2 I am marking. So as you know, Kirchhoff's current law, the current that is entering is equal to the currents that are leaving, right? So here this is the entering current into node B, that is I1. Then you have two leaving currents. One is BE branch and the other one is BC branch. So in the BC branch it will be I1 minus I2. Now if you observe, the sum of the leaving currents, that is I1 minus I2 plus I2 is nothing but I1. I1 is nothing but the entering current. So sum of the entering currents is equal to sum of the leaving currents here, right? Now this current that is flowing in the branch BC is I1 minus I2, and coming to node C, here you don't have any other branch, only one branch CD. So the total current that is flowing in BC will flow through CD also, right? So you can mark the same current I1 minus I2 here also. So you have to finish off the loop till A, you have to mark the currents. So again, if you come towards DE, again there is no other branch. So the same current will flow, I1 minus I2. Now, coming to the branch EF, you have, it's a combination of two branches, that is BE and ED. So these two are entering currents in the node E, and so the leaving current has to be sum of these two currents, that is I1 minus I2 plus I2, that is nothing but I1, right? So this is nothing but I1. So if you observe here, the current that is entering into node F has to leave, as there is no other branch. So the current that is entering into the node F is I1 here. So the same current here it is leaving. So our assumption is correct here. So after marking all the branch currents and the nodes here, now you can start solving your problem, right? Now identify how many mesh are there in the circuit, that is how many loops are there in the given network. So here if you observe A, B, E, F, A, as I said, KVL can be applied only on the closed loop or a closed mesh, right? Similarly, there should not be any current sources. So just follow my previous video, there I have explained KVL very neatly. Now another loop you have here is B, C, D, E, B. Similarly, you have another big loop here, A, B, C, D, E, F, right? So we don't have any current source in the given network, so no issue of consideration. So the two mesh I am going to consider here is A, B, E, F, A, and similarly B, C, D, E, B. You can take these two. Out of 3, you can consider any 2 here. So I am going to take these 2 networks. Now, you can apply your KVL. So KVL states sum of your potential drops plus voltage sources, that is EMFs, has to be 0 in a closed mesh. Now I am going to apply my KVL on the first loop, that is ABEFA. So resistor means it has a drop. So what is the drop across this resistor? You know V is equal to IR. So I is the current flowing in this branch AB is I1 multiplied by the resistance is 15. So it has to be 15 I1, right? And you know, as it is a drop here, so you can take the sign convention also, plus minus. This is also drop, no? Plus minus, and this is the source, minus to plus. As I said, plus to minus, it's a drop, voltage drop. So minus 15 I1 minus, again, the voltage drop across this 20 ohms resistor. That is nothing but the current flowing through 20 ohms multiplied by that value of that resistance. That is nothing but 20 ohms, right? So minus 20 into I2. Similarly, coming to EF branch, there is no element, so that you can leave. Coming to this branch, F and A, right? So it has a current source, voltage source. So minus 2 plus 50 is equal to 0, right? So this is the first loop equation that I am getting. Similarly, write KVL on second loop, that is B, C, D, E, B. In the same way, some of the voltage drops and EMFs in this second loop are also 0. So 30, the current flowing is I1 minus I2. So that you can write minus 30 into I1 minus I2. As it is a drop in the resistor, I am taking minus here. So here in the second branch, plus to minus. So it is plus 100. Then DE, there is no element. Coming to EB, again it's a drop, right? That you can take. Actually, you have to consider it as minus because it's a drop. But see, the direction in which you are moving is opposite to the direction of current flowing. Then it has to be 20 into minus I2. So minus of 20 into minus I2. So that will be plus 20 I2, right? Is equal to 0 here. Understood why I am taking plus here? I'll explain once again. See, if you are moving in the direction of current flow, then you take the as usual directions, right? Sign convention. But if your direction is opposite to the flow of current, then you take negative current, right? So the current flowing in this is negative I2. So that's why it is 20 into minus I2. As I have voltage drop in 20 ohms, minus 20 into minus I2. So that's why I'm writing it as plus 20 I2. Now simplify these two equations. So what I am getting is 15 I1 plus 20 I2 is equal to 50 from the first mesh, and the second loop or mesh I am getting it as minus 30 I1 plus 50 I2 is equal to 100, right? So this is equation number 1 and equation number 2. So if you observe, you have two equations and two unknowns, that is I1 and I2. So this is a simple mathematic problem here. If you can solve these two equations, you will get the two unknowns I1 and I2. You will be getting three unknowns and three equations, so which will be difficult to solve. So for that they are using Kramer's rule. So Kramer's rule, you have to find the determinant. So that is nothing but you just write the constants of these terms here. So 15, 20, minus 30 and 50. This I think you might have learned in your M1 itself. So just AD minus BC here. 15 into 50 minus of minus plus 30 into 20 here, right? So that will be the determinant. Here you will get it as 1350. Then D1 you just replace that first row with this values 50 and 100 here, then 20 and 50. Again use this AD minus BC, that you will get it as 500. Similarly, find the value of D2. So replace second row. So 15 minus 30 and replace with 50 and 100, the second column, right? Now again apply AD minus BC. So here you will get it as D2 as 3000. So after finding the value of D, D1, D2, now we have to find out the values of I1 and I2. So according to the Kramer's rule, the value of I1, you have a formula that is a D1 by D. Similarly, for calculation of I2, formula is D2 by D. So the value of determinant D1 is 500 divided by value of D is 1350. So the value here, it will be 0.37 amperes. Similarly, D2 is 3000 divided by D is 1350. The value here you will get it as 2.22 amperes. So, after solving this using Kramer's rule, the two equations, the two unknowns, that is I1 and I2, we got the values as 0.37 amperes and 2.22 amperes respectively. And the last step to complete the problem here is, the question is find the various branch currents. But till here we found only I1 and I2 values. So mark all the branch currents in the circuit itself here. So the branch here AB has the current of I1. So the value of I1 is 0.37 amperes. So write it here, 0.37 amperes. Similarly, from node B, you have two branches, right? BC and BE. In the branch BC, the current is I1 minus I2, right? So I1 is 0.37 and I2 is 2.22. So I1 minus I2 value, I'll get it as minus 1.85 amperes. Similarly, here in this branch, I2 value is 2.22 amperes, right? So the remaining all are also same. I1 minus I2, that you can write the same current, minus 1.85, right? Now, you may get a doubt here. See, the value of I1 minus I2, that is the branch current in the branch BC is minus 1.85 ampere, right? So the current value always has to be positive only, but it can never be negative. But it is showing here as negative, right? So there is nothing to worry here. The direction that we have assumed is wrong. That's why it is indicating a negative sign. So I1 minus I2 is nothing but 1.85 amperes only, but it is flowing in the opposite direction to that of the direction that we have assumed using our KCL in the beginning of the problem. The next question that I have chosen here to explain KCL and KVL is this type of bridge circuit. Question is like this. Find the current in branch AB in the DC circuit shown in the figure using Kichoff's laws. So here this is the branch AB where we have to find out the current through this branch only. Then all the resistors are of 1 ohm here given, and 4 sides you have the current given. So 16 amperes is the entering current, whereas 5 amp, 4 amp and 7 amp, all the remaining 3 branches, it's a leaving current. Now let us solve this, as they have marked only 2 nodes A and B. So I'm marking the other 2 nodes. Let us call this as C and call this as D. Right now, as they are telling, this is the 16 amperes entering at node A. So node A, you have other 3 branches connected here, that is AD, AB and AC. So to first mark all the branch current directions here, apply KCL at node A. After applying KCL, so as KCL says, sum of the entering currents is equal to the sum of the leaving currents. Here 16 amperes is the entering current, and I am assuming in this branch it is leaving as I1, and in the branch AB it is I2. Then here, what about the branch current AC here? So 16 amperes should be equal to I1 plus I2 plus current in AC branch, right? So that is nothing but the sum of the currents that are entering is equal to the sum of the currents that are leaving. So as I have 3 currents leaving, I have assumed I1 and I2 as 2 branch currents, and the third branch I am taking in terms of I1 and I2 only. So the current IAC is nothing but here 16 minus I1 minus I2. So after applying a KCL at node A, I got all the branch currents here. It is I1, I2 and 16 minus I1 minus I2. Now, the 16 minus I1 minus I2 will enter into node C, and node C has a leaving current of 4 amperes and also another branch here BC, right? So this also I am assuming it as leaving here. So if you apply KCL at node C, the current in BC, that is leaving, plus 4 amperes is also leaving. So leaving currents is equal to entering currents. Entering current is only here the branch current AC, that is nothing but 16 minus I1 minus I2. So the branch current I in BC is nothing but 16 minus I1 minus I2 minus 4 amperes. So that is nothing but 12 minus I1 minus I2. So the current in branch BC here is 12 minus I1 minus I2. So I have marked the current in the branch BC here. So applying the KCL at node C, I got the current here. Now coming to node B here, you have 4 branches connected at node B. One is 7 amperes leaving, I2 entering, and 12 minus I1 minus I2 entering. 2 currents are entering and 1 is leaving. What about this branch IDB? That is also, you assume it as leaving. Now we have to find out the current in BD branch. So applying KCL at node B, will get it like this. Sum of the entering currents is equal to sum of the leaving current. So at node B, entering currents are here I2 plus 12 minus I1 minus I2. So I am writing down I2 plus 12 minus I1 minus I2. Similarly, the leaving currents are 7 plus the current in BD, which I have to find out. So here I2 will get cancelled. Current in BD is nothing but 12 minus I1 minus 7. So that is equal to 5 minus I1. So the current in the branch BD is 5 minus I1 here. Now this 5 minus I1 is entering into node D. Similarly, another current of I1 is also entering into node D. So at node D, if you can write KCL, sum of the entering currents 5 minus I1 plus I1 is equal to leaving current, that is 5 amperes. So this will get cancelled. So 5 is equal to 5, right? So with this, the network is completed, right? So our assumption of currents using Kirchhoff's current law is correct here. Now, second step is to find out these currents I1 and I2, similarly the other branch currents, right? So, for that we have to apply KVL on this network. So, after applying KCL, I have marked all the branch currents on the given network. Now, to find out these branch currents, we have to apply KVL. So we have assumed the direction of branch currents only using KCL. To find out the actual values of these unknowns, that is I1 and I2 and also the branch currents, now we have to apply KVL. So to apply KVL, first of all we have to find out the closed loop. So if I observe here, I found A, B, D, A as one closed loop. Similarly, A, C, B, A is another closed loop. Also, we have here A, C, B, D, A, another closed loop. If you see the circuit here, according to our assumptions, we have two unknowns I1 and I2. So, select any two loops out of these three loops. Then write down the mesh equation, or what I say is KVL equation, and then solve for the two unknowns from the two equations. So, let us do that. Now, I am going to apply KVL along the loop. First A, C, B, A. So if I apply it along A, C, B, A, now In the branch AC, according to KVL, sum of the potential drops and voltages should be equal to 0. So here 1 ohms is a resistor, so where I have a potential drop here. So the potential drop in 1 ohm is, that is nothing but R into I. So 1 into 16 minus I1 minus I2 is the voltage drop here. As I am moving in the same direction as current, so this is a drop, I have to write it as minus. So minus 1 into 16 minus I1 minus I2. Similarly, in the branch here C to B, 12 minus I1 minus I2 into 1 is the drop. So 1 into 12 minus I1 minus I2. Remember, always drop you have to write it as minus, and it's a voltage source means you have to take it as a plus sign. Now moving on to BA branch, if you see here the drop here is I2, but as you are moving in the opposite direction towards the current, so you have to take minus of minus I2, that is nothing but plus I2. Plus I2 is equal to 0. Now we have to simplify this equation. So that will be here minus 16 plus I1 plus I2 minus 12 here, minus of minus plus I1 plus I2 is equal to 0. So here what I am getting is I1 and I1, 2I1 plus 3 times I2 is equal to 16 and 12 I have, that is equal to 28. So this is one equation I am getting in terms of I1 and I2, right? So as they have asked the current in the branch AB, so we have to find out I2, right? So write down another equation in terms of I2 so that we can solve here. Now writing the second equation, that is along the network ADBA, choose the network loop ADBA here, then I'll get minus I1. Similarly here, if you are going, as you are going in the opposite direction to the current here, so plus 5 minus I1 into 1, then here coming to here, so this is also you're moving in the opposite direction, so minus of minus plus I2 is equal to 0. Now simplifying this, what I am getting is minus I1 plus I5 minus I1 plus I2 is equal to 0. So that is nothing but minus 2I1 plus I2 is equal to minus 5. So these are the two equations I am getting. Now we have to simplify these two equations to solve for the value of I2 here. So here I am writing down equations one under the other. As these two equations are very simple, I am just adding so that I can cancel my I1. What I am getting is 4I2 is equal to 28 minus 5 is 23. So I2 is equal to 23 by 4, which is nothing but 5.75 amperes, right? So this is nothing but the current that is flowing through the branch AB here. See, the current that is flowing through the AB branch AB is nothing but I2, which is equal to 5.75 amperes.
For more videos, please do like, share, subscribe to our channel. Let us know your suggestions and queries in the comment box. Thank you.